Ah, now streaming live on YouTube. I see it.
All right, cool.
Ah, now streaming live on YouTube. I see it.
All right, cool. Okay, we are live. I'm just going to send a message out to everyone so they know where to go.
Perfect. Okay.
Okay, message is sent, and I think we have 1 minute left to kill before we kick this off.
Yeah. Sweet. So I'm just looking at sprites, widget sprite builder in your YouTube channel. You have so much, so I'm impressed. Nice. I really want to play with it.
All right, cool. Well, it's yeah, you can do a lot of stuff with it.
Have you ever used Unity 3D with C#?
A little bit.
Okay, in it, the asynchrony stuff, there's like core routines and things like that. It's not as clean as Dart at all. So whenever I'm like coding there, things that take time, I was like, oh, I wish this was in Dart. And then, yeah, maybe if I can start using Sprite Builder now.
Yeah, no, I just, yeah, so many times I wished I didn't have to code in C++ or...
Oh, C++, definitely.
All right, I think we are going to kick this off. We have, I don't know if we can see how many people we have here, but I am Victor, and I'm hosting the Flutter Sweden meetup. And today we are here with Gazian, who's joining us from Turkey in Izmir. And Gazian is a teacher at the university, and he teaches game development and app development, right?
Yes.
So how are things in Turkey?
Things are good. It's getting warmer, but we have to be locked in at our houses. So I'm hoping like in a couple of weeks or a month or so, if it gets better, we'll start going to the seaside also, to the beach.
Yeah. So can you tell me a little bit more about the classes you're teaching?
Right. So I've been teaching for like 3 years, the mobile application development course. Actually, I've been teaching like for 6 years the course, but I kept changing it. So I tried, I don't know if anybody remembers, there was Accelerator Titanium back in the day, in which you could do cross-platform JavaScript mobile apps before React Native. So I tried to start with that, etc., because I knew that people always want to have the iOS and Android versions. And for our students, at least, it's really difficult to learn both of them. So, but I was always looking for frameworks, and I could never find a good one. But for 3 years now, I'm doing React Native plus Flutter in my course. And since they are similar in terms of architecture and everything, our students are actually creating really good apps. And some of them are graduated and like they are working on good paying jobs and everything. So I'm really proud about that.
That's cool. So can you tell me a little bit more about the game development? You mentioned before you primarily use Unity for that.
When I was doing my PhD in the United States, my PhD dissertation was about using games for physical therapy, occupational therapy. People who had strokes, they have to keep exercising their lost arms or whatever motion they lose. If they keep exercising, then they actually get better. And we developed games that were tailored for them and did experiments, etc. So that was my entry to the game development world, which I know every programmer is like, I want to do games, and then they start programming.
Yeah.
And then thanks to that, I was able to come here, and they really wanted to do a game development courses here. So I was able to come here to Izmir University of Economics. The name is Economics, but doesn't have anything to do with it, yeah, I'm in the computer engineering department. I was here and then started developing, teaching about game development here. I have a couple of games that I haven't released, but hopefully I know you are really big about, Sprite widget in Flutter. So I just learned it like 10 minutes ago.
Right.
I want to use it.
Yeah, I've been working a lot. My background is in game development. So I worked for some big game companies over here in Sweden. And then I worked for a while for Zynga. I built tools for building games. The biggest was Sprite Builder. They used it for a bunch of their games, but also a lot of other companies. And eventually, I guess I ended up at Google, and they wanted me to sort of restart that from scratch. So I did a Sprite widget for Flutter, which was actually originally part of Flutter, but when I left, they sort of pulled it out into its own.
I see. So that was a Google project. Google was building.
Yeah.
Okay. Now I see. Very nice.
Anyway, so how did you get into Flutter?
Yeah, so I worked at Google very briefly. I was an intern there for 3 months in 2010, I believe, when I was doing my PhD. In one summer, I was able to work as an intern there. And I was doing something totally irrelevant, but there was a hackathon back in the day. They wanted to put like JVM inside Chrome, and they wanted to see what we can build if we have another language other than JavaScript, what we can build in the browser. And I was the 4th place in the hackathon around Google. And so later I followed it. Other friends of mine work there, so they let me know that that hackathon thing you worked on, that's becoming Dart VM, and like that's how I got to learn it when it was first released. And ever since, and I really loved the asynchronous, async await stuff there. I was seeing it in Java, like futures, etc. It never made sense to me, but with Dart, it made perfect sense. And ever since, I'm trying to find ways of using Dart in different projects of mine, like personal stuff and everything. And that's how I was an early Dart user. I've like pull requests to very simple libraries back in the day, and so that's how I was following it. And I remember like in one conference, they showed the rotating cube, and then they said maybe we can do mobile apps with it, and everybody was clicking on that apparently. So they said, okay, we should do Flutter. As far as this is my bad recollection of the history, but I was following it ever since it came out, and teaching it in my courses for 3 years now. Probably the first university to do that VR. But yeah, that's how I got into it.
All right. Very nice. So I think for today, you have a presentation that's going to be around like 30-40 minutes. And obviously the futures and async is a very central part of any sort of Flutter programming, I would say. As soon as you leave just doing a simple layout and want to actually do something, it's something you're going to need to use. So it's, I think, a very important topic to get the grips of.
Yeah.
But I think we also have a little bit of a chat going on here. So I think what we can do is make it a little bit interactive. I don't know if you see the chat or if you want me to interrupt you while you're having your presentation, maybe, and we can.
Yeah, feel free to interrupt. If I see it, I'll try to answer. But yeah, feel free to whenever it feels normal. Go ahead.
Right. Okay, so we have a bunch of people who joined us here on Zoom, and I think you probably a couple on YouTube Live as well. So yeah, I'm just going to leave it to you, and I'm super excited to hear your presentation.
Okay.
And see what I missed.
I'm sure you'll know all of it, and you would be a better guest actually, but you have to have somebody else, I guess, right? I'm really honored to be here. Thanks.
We're super happy to have you.
Okay. So should I share?
Yeah, go for it. I'm going to mute my video and audio here.
Okay. So you probably can see my screen now. And I'll do this. Okay, is everything good? Right, thumbs up. Yeah, okay.
Everything looks great.
Okay, so let's start. Okay, thank you, everybody. Thank you very much, Victor, for having me here. I'm really honored. Today, I'll try to talk about futures and async, and I'll try to give a natural reasoning for it. Hopefully, like if you're even a programmer, you'll get something out of it. So beginner, intermediate, and then I'll give some actual tips and stuff. But hopefully, the first part of the talk will be for everybody. And I've never been to Sweden. I'm really honored to be in Flutter Sweden meetup as a guest, and we have super respect for the Swedish people, the Nordic people in general. I had a friend from Sweden that he was a really nice guy, and I loved ABBA, and well, when I was a child, more ASO base. And we also just last night we were watching The Ritual, the movie that was in Sweden, and Midsommar before that. So we're kind of into horror movies with my wife. So that's what I know about Sweden, and I'm really happy to be honored to be here. Yeah, we talked about myself when we were chatting earlier. So let me talk very briefly. After I graduated in Turkey as a computer engineer, I went to the United States to get my PhD, did some games there in my PhD. And then while I was at Google for 3 months as an intern, I got to know Dart. And then I came to Turkey, to here, Izmir on the West Coast. By the way, if you want to come visit, you're always welcome to. You can just chat me, ping me. And I'm in Izmir University of Economics in the computer engineering department, and then mechatronics I switched to. But anyway, so I'm teaching mobile applications and games. And I also have my company on the side, doing some robotic projects and developing mobile applications with Flutter, together with my students. So that's how I kind of got into Flutter. We're actually developing applications for a bunch of clients. So yeah, let's get to the talk. So nobody likes to wait, right? Let's say we went to a mall with a bunch of friends, and this guy wants to get some hamburgers, okay? And he goes to the counter, and they say, okay, it's gonna take 5 minutes. So what does he do? If he waits here, then his friends in the table are like in agony, or where is he? I want to tell him something, etc. I know that you get this reference. So he's locked here. He cannot go to his friends. His friends are sad. So this is like your app not responding to you. You can tell the analogy, I guess. And then instead, what we could do, instead of having your friends wait at the table, some restaurants give this pager to you, little plastic device. And when your food is ready, they press a button and it lights up and vibrates, so you know, and you get it, right? So instead of making you wait here, they give you this pager, and then you get to your desk, and everybody's happy. You talk to your friends, etc. And at some point, it starts vibrating, and then you finish your sentence. You go get your hamburger, and then come back, right? So this is the ideal situation. So in this alternative scenario, you didn't have to wait, lose time waiting. Instead, you had some productive time while waiting for your hamburger, right? You did other stuff while waiting for the hamburger. You didn't watch the hamburger guy waiting, you didn't watch the hamburger being made. You went and did some useful stuff. So that's the main reason why we're talking about asynchrony. That's the whole point of asynchrony. Not making the computer wait for stuff, not making the user wait for stuff more. Okay, so let's talk about some code. I wanted to make this as concrete as possible, because when you start talking about async, etc., okay, this happens then, etc., but you want to see some code usually. And with Flutter, you can go through debug line by line the whole framework. So if you want, you can take a look. But here is a very simple but concrete way of talking about it. So we have a processor. We have one processor, which means we have a single thread in Flutter usually, unless you create an isolate yourself. But in general, your application is a single thread. You can think of it as a single processor. And you have a bunch of code, right? You learned how to program. The processor goes through each line of code one by one, right? This is obvious, and this is how we learned how to program. But the thing to remember here is, without finishing this line, the computer cannot go to the next line. So that's the whole point of having sequential programming, right? After this line is complete, then I can go to the next line. So, but if one of those lines make the computer wait, we cannot go to the line after that. So that's the whole idea here, I'm trying to say. And then if we look at Flutter or any other interactive application in general, we have an event loop, which keeps looping like while true. And then in that event loop, sometimes your functions are called, right, for various reasons. You write a function, give it to the framework, and it calls your function to create your UI because of a button click, etc. You provide a function, it is called. You return from that function, event loop can continue. And at some point in the event loop, there's a function that refreshes the screen. So that, for example, if you scroll a little bit, it comes to this function, draws it again a little below, right? If this function doesn't work, you try to scroll, but it doesn't scroll. So it's like your app is dead or like hung or something like that. You froze, right? That's the experience you get. But if it doesn't happen, if it comes to this function that refreshes the screen, everything works fine. Your application is really fluid. Flutter, they say, tries to do 60 frames per second. So this has to happen 60 times every second. And nobody should stop this processor from coming here, okay? And then it goes back and event loop continues. But let's say in our function, we were able to do something like this. In this line, we start like a 1 GB large download. It takes some time, and we keep the processor hostage here, captive here, right? If this happens, it's not going to be able to come to this function that refreshes the screen. Therefore, our application will freeze. If we try to scroll, it's not going to react to us. And then the operating system will kick in and it'll say, hey, this seems like it's dead. You want to kill it, right? This is the situation. And this was quite easy to do in earlier Android versions, Android SDK. I'm not sure about the latest ones. They try to discourage it as much as possible with the IDE. But this was possible, and this is possible in a lot of frameworks. In Flutter, this is almost impossible, at least using the regular stuff, unless you do a for loop yourself or something. But everything in Flutter tries to prevent that. And this is the whole point of today's talk, asynchrony, not making the processor, not keeping it captive like this. Instead of keeping it captive while the download is happening, we could have done the restaurant approach, right, with the pager. Instead of making him wait, give him a pager. Hey, this is your pager. This is your future object. This is your pager. Go ahead and do whatever else you want to do. And then we're not captive there. We go back to the function that refreshes the screen, and everything is happy. We can scroll. Other things work in the app. That's just fine. Okay. So, okay, what happens when this is over, right? There's also a function that continues unfinished tasks here, which I wasn't showing, but it always goes into it also. So this is your whole event loop. So here we are going around, and at some point, this download is over. And this pager says, hey, I'm done. This future says, I'm done. And then the processor, when it gets to this function that continues unfinished tasks, it says, okay, we have a task that is finished already. So let's do something about that. It's time to do something about that. This is like you sitting on your table with your friends, and the buzzer buzzes. And then okay, let me finish my sentence. Okay, let's go get the hamburger kind of thing. This pager knows about another function. When we were starting this download, we gave this pager a function to execute when that's complete. Okay, this future object, we gave a function. When you're done, please execute this, we said, so that we can use this download that we finished, right? So knowing that, our processor, through this pager future object, goes to that function, executes that, and then comes back, and then event loop continues. Okay, this is more or less really what's going on without the actual details, but this is the concrete idea that you should have. When you do it like this, everything is happy. Function that refreshes the screen executes, and it is updated. So remember, in our example, we were doing a download, which is obvious, right? Everybody knows stuff from the internet takes time. So you should do it somehow asynchronously some way. But there is something that a lot of time overlooked, reading a file. So this file system is much slower than the CPU, even if it's like an SD card. Okay, so these are numbers that I made up, but I'm sure it's close to real. If it takes t amount of time to get this event loop, it will take 10t sometimes if you are reading a file. So if I'm at this line, reading a file and using the result of that file in line 5, I'm actually preventing it from going through the event loop, and your application will stutter if this happens. And if your framework, whichever framework you're using, C#, Python, etc., if you read a file in one line and in the next line you can use it, then it is doing this bad thing, bad situation. This situation is happening there, and you're actually keeping the thread busy while reading your file. It could have done other things. In Dart and Flutter, all such functions are asynchronous by default, so you're not able to do this problem. You're not able to have this problem in Dart and Flutter. But if a framework lets you read files synchronously, your application will stutter at some point. So another reason that Dart and Flutter is good about this. So if you don't want to wait, what did we have? We had these pagers, right, as an example. It will be our future object. You need an IOU, right? I owe you something, I'll give you something, or a future or a promise object. In JavaScript, the new JavaScript, you have the promise, very similar to future we have here. So for example, you get your burger, you pay for your burger, they give you a receipt. With that receipt, later you get your burger. This is like your IOU, your pager. Or in general, we can think of it like this. You can think of this future object like this. You have a box, you're given a box. On the box, it says, this box will contain your answer. It'll open by itself when it's time. Don't try to open it yourself at the moment, okay? If you cannot simply do it at the moment because the data is not there. You know, in Stack Overflow, you see questions all the time. Hey, I call this function, it gives me a future. How do I get it out? Well, the answer is you cannot get it out. You'll just have to learn how to work with that future object and write code so that it executes when the data comes in, not the other way around. So I think this is a good analogy for that. If you internalize this, then everything is makes much more sense. So why waiting versus non-waiting? What's the whole point, or how much of a difference does it make? So let's give an example of cooking at home. Let's say I'll bake beans and then cook rice. If I bake the beans, finish it, and then start cooking the rice, then I'm losing a lot of time. Why? Because I start something, let's say, start frying the onions. I wait for the onions to fry, to become pink. And during that time, I could have done something else. That's time lost waiting for something else to complete. Instead, if I was doing asynchronously interleaved fashion, which is what we do naturally. So you prepare the onions while waiting for them to turn pink. You prepare the rice. You switch back and forth between the tasks to use your time as productive as possible, not wait on something, not watch the onions turn pink, right? And another thing here is we're not actually busy during these white times, right? When we put them aside like this. If in the synchronous approach, we're like watching everything happen. In the asynchronous approach, we're starting them, going away, doing something else, right? And one example I can give here is, let's say the phone rings. In the synchronous approach, you say, I can't answer, I'm watching the beans bake, right? But in the asynchronous version, you can say, yeah, hey, yeah, I'm cooking, what's up? It can wait, I'm not doing anything immediately. So this is a very close analogy. And this is actually what we're doing if we are doing synchronous programming. So I know all the examples sound like, yeah, duh, but that's how, programming, this is how it's working when you're actually doing synchronous programming. And why are we doing this? Why are we doing synchronous programming if it's that stupid? Because it's more straightforward, right? That's how we learn how to code, this line and that line and that line, right? That's how we learn. And it's more straightforward. After we let's get the data, let's do something with the data, right? In the next line, that's more natural as a programmer. And async is more involved. You have to create another function, etc. But it, of course, wastes less time, stays responsive, and etc. And if you're in the sync world, if you see this, for example, in your app, the app is saying, I can't answer, I'm watching the beans bake. So somebody blocked the UI thread and it's waiting for something. It didn't reach the event loop. This wouldn't have happened if it was programmed asynchronously. Okay, you may think of threads. Let's get another thread, which is like getting one more person, one more processor. Is this a solution? Maybe, but usually it's difficult to get threads to work right. I don't like multi-threaded programming. I'm holding a data in my hand. Somebody else changing it is not, very pleasant. You have to protect yourself in all kinds of ways. And let's think about the thread situation, actually. So if you have multiple threads, multiple executions are happening, but when things are happening at the same time, you can have possibility of race conditions. You hold something, somebody changes it, like I said. And also multiple threads can be waiting at the same time also. But of course, you would have a main thread that's not never waiting. But in general, there is this race conditions is a problem. In the async world, you only have one thread in this case, in the Flutter's case, and we have this blue task. Let's say it starts to download something here. It takes some time. In the meantime, we can do this green task. And when the blue stuff is downloaded through the, when they call our separate function, we can continue our task. This is more or less what goes on. So in the sync world, thread or not thread, in the sync world, to go to the next line, well, to continue your task, sorry, you just go to the next line. It's very easy, very simple, like I said, because that's why we do it. In the async situation, to continue your task, you have to provide a separate function, which is a little more complicated rather than compared to going to the next line, right? So you need a callback function here. And if we zoom into here, this is where the future object fits in. Instead of passing around callback functions, we use a future object. And when we start to download something, it gives us a future object. And from there, we can go to other stuff. The processor can go to other stuff. And our function actually returned here. And then when the download finished, that future object, we earlier assigned the function to it. And that function is called, in which I can continue whatever I was doing. It has to be another function like this. But this way, I'm able to, using these future objects, I'm given that, and then through that, I can continue with my function. And others can continue when the thread is available. It is handled by the event loop. And in this YouTube link, there is the official videos of Flutter guys, Flutter people, really nice videos. You should watch them also. The thing is, this is handled by the event loop just like any other event. So notice that this part is white, even though we're doing like downloads and things. But our processor is available to do things, right? When somebody touches, for example, at this time, we can handle the touch really quickly rather than make them wait. And all of them are handled by the event loop, like I said earlier. And if it was sync, if we were blocking the thread, it would be like frozen during this time if I touch, and then the touch would be responded to around here. So, but if we have the async, then we are responsive, like I said. Okay, so this future object, it's like the restaurant page that I was talking about earlier. Thanks to it, different parts of your code and the framework and your code don't have to know about each other. Instead, they use this future object as a broker, as a middleman. Okay, so the producer, when we ask, let's say, please download this file, it says, okay, I'll download it, but for now, here's a future. I'll give you the result through it once I'm done. And then the consumer gets it, the guy that the person started that download, says, great, I know what I'll do when you're done. And we just attach a function to it, and we get the other work done in the meantime, and the producer works on creating the result. And when it's there, it says, I'm done, here is the result through this future object. It calls the function that we attached, and we say, great, the code that I attached to it executed, I'll use the result here. So this future object is like a broker between this producer and consumer. Otherwise, they would have to know about each other. There would be high coupling. So let's look at some code finally, right? So this is a very simple piece of code for single values. Let's say if you have int in the synchronous world, in the asynchronous world, you have future int, the generic type. It's a future object that knows that it will give an int over. So it's typed like this. So very simple code here, int get val, return 1, right? Just return 1. And in my main function, I say int val is equal to get val. So I call that function, get the 1 from it, put it to val, and print that val, right? Print that value. Simplest synchronous function. In the asynchronous world, get val would return a future instead of an int because we don't have the value yet. And here's a way of creating a future. I could use delayed or something also. But this returns a future. And the main function calls getVal, receives a future object, and then the future object has a .then method. We call the .then and give a function to it. So this is the separate function that I was talking about that will be called later, not now. So after this function returns, when that future completes, then this inner function gets executed sometime in the future. But it's like a closure, so it shares the local variables of it, etc., etc. But still, it's a separate function, a little more complicated than just going to the next line. Okay, we also have streams. I don't want to spend a lot of time on it. It's very much the same thing, except it provides multiple values in the future for things like your stock ticker update, your currency rates, whatever you want to show in your app, or like a live value being fed to your app. You can use streams. And as data comes in, you use them just like the future. And in streams, the situation is similar, but a little more interesting. So for single values, we had this. For multiple values, these are like your lists or arrays or things like that. This is a list in Dart. And the parent class is iterable. And to any iterable, we can attach a for loop. For int I in iterable, we can say, and go over all the items one by one. The asynchronous version of it is stream. So stream is like an iterable, but you don't know the values. You don't know how many they are. You don't know if a value will appear, etc. For example, you can get the keyboard as a stream. Whenever I press a button, another data is sent, another key is sent through the stream. So you don't know what's going to happen. You just have it. You receive it in the future. You receive elements in the future. So we can say stream.listen, just like future.then, and we can attach a function like this, which executes time and time again every time data arrives at the stream. So this table is quite instructive for it. So Dart, so far, so good. This is the case in any language. You can implement it like this in any language. Now we're starting to talk about what Dart offers, right? Future is great, but writing sync code is easier, right? So if you look at here, this synchronous code is much easier than this asynchronous code with the functions and everything, right? That's why, yes, you should do it asynchronously, but maybe in not all frameworks, if you're not forced to do it, maybe you don't do it, right? But Dart language and standard library have async support. So Dart have async all the way through, which makes it, makes it easier for you to embrace this asynchrony, and which makes writing async code pleasant. So I'll talk about async await to show how Dart supports us for asynchronous programming. There's also generator stuff I'll very briefly mention in interest of time. I'm not going to go in detail. Okay, so this is our earlier example with the single value. With the this is getVal. This is the future version of it, right? We say .then. This in the middle, as you can see, it looks very much like what we have on the left, just like the synchronous version. Val is equal to getVal. We have int val is equal to await getVal, right? And we have this await as a difference, and we have these async marks in these files, and we have the future here. But other than that, it looks like after getting the getVal, after getting the val, you're going to the next line here, which is perfect because that's how we are used to programming. Okay, but this is what happens. On the right is what happens behind the curtains. You get to write your asynchronous code like this. The compiler or whatever the Dart system converts it to this and runs actually that. But you don't worry about it. For all intents and purposes, it works like this. So let's take a look at the code a little bit. So our getVal is returning a 1. You can see that we're not actually creating a future here. We're just returning the int value ourselves. And because it's marked as async, it creates implicitly a future object for us. Okay, so this is nice. We're just returning the value that the future should pass over. And this future object implicitly created is returned from this getVal. And when we put an await in front of it, we get to do this if we are also marked as async. If we put await in front of it, then we don't treat it like a future. We treat it like an actual value. Okay, so and then we use it in the next line. Like I said, this is what happens behind the curtains. And after this getVal, the rest is a separate function actually. But for us as the programmer, it looks like a single function. And we can do step-by-step coding. We can do for loops. We can do branches that await and not await, etc., which is not possible with all functions sometimes. But this is great. We get to write asynchronous code just like synchronous code, except we have to mark our functions as async. And in it, we can use await to treat it like right now, even though it's in the future. So this executes. After that, the rest executes. Okay, so I hope this was clear. So let's remember how we continue, right? In the sync case, we go to the next line to continue, and we make the processor wait. In async case, we have to provide a separate function that is called by the system. In this third thing that I just introduced earlier with the code, with async await, we still are asynchronous, so these parts are not busy anymore, but we do go to the next line to continue as the programmer. So it's the best of both worlds, as you can see. We are async, which is great. We are responsive as the UI. We are responding, we don't freeze, but we go to the next line, as opposed to, you know, using these separate functions, etc. Okay, so this is the best of both worlds, this async await, and you should strive to use it if you're dealing with futures. It makes everything much easier. You can do try catch, and you know, everything works like, almost everything works like synchronous code. Okay, and yeah, so every now and then you'll see a Turkish word here because I translated it from an earlier talk. So sorry about this. This is end. So yeah, with streams, we have very much the same thing. We had stream.listen earlier, you remember. And with that, with iterable, we could do for. With stream, we could not do it. But with streams and async, we can do await for, which is just like a for loop. It works just like a for loop, but it turns once and then it waits for the next item. And when an item comes, it turns one more time. Why is this great? Because you can have your local variables, etc. You're not leaving the function. So this is the whole point. When you leave the function, your state is lost. Even if you have a closure and everything, it's not the same. But since you're not leaving the function, just attaching an await for on a stream is very powerful. If you ever program like socket programming or something like that, I did it once with Dart. It was very pleasant, as opposed to the other way around that I had done before. I just get the socket, attach an await for to it. Every time something comes, you have one more loop. It is great. Okay, I promised that I would talk about generators very briefly. So this is a way of creating basically streams, instead of using a stream controller. If you want to create your own streams, if the system is not giving you a stream, you want to create your own, you can use a stream controller, or you can write a generator async star function. So if you write an async star function, this star is like multiple items you can think of. Implicitly returns a stream. You don't return anything. You say yield val. Every time you say yield val, through that implicitly created stream, that val is sent over. Okay, so this function actually creates a stream for you. It's this easy to create a stream. You don't have to deal with the stream controller, blah, blah. It's really crowded with that, but this is very clean, very simple. There is the synchronous version also, of course. It returns an iterable, and this exists in some other languages also. Similarly, you could just put everything in an array, but maybe you don't want to create them immediately. But the async version, of course, the stream is more powerful, and the difference here is this executes all at once. This executes at different times. Okay, so async in Dart is great. What about Flutter, you might ask? So Dart is a language, Flutter is a framework. So all the stuff that I talked about has no idea about Flutter. So you have to be careful. So we have Future Builder and Stream Builder widgets, which I'll talk about, which directly support asynchrony. And this is how you can write your apps. But sometimes it may get a little crowded if you have too many of them. Then you can use set state yourself when the future or stream is complete. So this is set state is what we call whenever something changes that should be reflected on the screen. We just call set state, and through that we change the UI, right? And you have to be careful about something here. Your widget may not be mounted anymore because Dart doesn't know about Flutter. You started async Dart function, it will continue whatever you do in Flutter. And when you go to another page, for example, if you try to do something about that page that's not around anymore, you get an error, which I'll demonstrate soon. And the block pattern, if you ever want to use it, the block pattern, it uses streams heavily. So you should understand this stuff before moving to block. Okay, so let's talk about the Future Builder, Stream Builder, right? In Flutter, it's all widgets. We create a widget hierarchy again and again in our build function. We don't maintain a tree of widgets, but we recreate it. We get to create it from scratch every time, which is the whole point of React Native, which is why they are so popular. It's easier for the programmer to create this tree. It's not easy to maintain this tree. So that's why we keep creating a tree in Flutter, right? But we create it if we have the data. If we don't have the data, we have to show something like loading or something like that. So what do we do if we don't have the data now? We use a Future Builder widget. This is just like your text widget, whatever widget. You just put it in your tree, give it a future, and it will call your builder function that you put into it. You give it, and it calls it immediately, and it says, hey, data is not ready yet. What should we show? You say, okay, show this kind of a loading, circular progress indicator, whatever. And then it shows that, And when the data arrives, when the future is complete, then it calls your builder function again, in which you can use the data and create the actual UI. This is more or less how the future builder works. This is very easy to use. I suggest you use it if you can. And there's also the stream builder counterpart, which is in which you just attach a stream, and then every time new data comes, you get to recreate this part of your tree, part of your UI. Okay, that's all good. And this is some example code, future builder, stream builder. You give it a future, and you give the builder function. It calls it immediately. There's no error. If there's an error, you get to also create a text or maybe a retry button, whatever. But if there's no data, which is the case in the beginning, you show a progress indicator, and then it is called again when the future is complete. Then you get to create your, whatever UI you want to create. Same for the stream builder. As you can see, they are pretty much the same code. This executes multiple times as data arrives. Okay, so there's an alternative. As you can see, there is some boilerplate looking like code, right? And as you have more of these, this gets really crowded and can get hard to manage. Sometimes you see many times your build functions are called, maybe all kinds of issues you may run into if you use too many of them nested and everything. There's an alternative. If you want to keep things simple, you can manage the future or stream and use set state yourself, okay? Instead of using a future builder. Here's a very simple pseudo-ish code example, almost real. So we have a stateful widgets state class here, and we have a state variable. And stateful widgets state class has an init state function. This is called just once in the beginning, and build is called again and again as it needs to be built with set state. Right? In the beginning, you can call this start async job function, which is an async function. So you can call these async functions like this to like creating a thread that will keep running by itself. Okay, you don't wait on it. You don't do. If you do, then it's also fine. You can do, but it's like creating a thread, spawning a thread, and then it executes this obtain function, which is like an HTTP call, let's say, and then it waits here, and the build function is executed, of course, and our state is null. If state is null, return loading. So we show the loading, circle progress, whatever, and then when the there was supposed to be a effect here. When the obtain function returns the await, the future completes, then you call set state, put that R into your state, and this set state recalls your build function. State is not null anymore, so you create your UI. So you can manage your futures like this, but there's a catch here. If this user info goes away, it's not in the hierarchy anymore. This happens when you go to another page in your application. If it's destroyed, disposed of, your function will continue to execute. Okay, so this is Dart, this is Flutter. Dart will not care about it. It will continue to execute. Before obtain is over, let's say we move to another page, obtain will be over, R will be here, and set state of this will be called, which will result in the set state called after dispose exception. Yes. And this happens only occasionally, like when you move away, etc. And then you pull your hair, or why is this happening? It's not happening for me, etc. This is the reason, because your widget is not around anymore, but your async function is continuing. What can you do? A very simple solution is writing a set state if mounted function yourself and calling it only mounted is true. Only if mounted is true. Mounted becomes false when this happens. But this may not be perfect, because you should also maybe stop your async function, right? That also makes sense. You can put if not mounted return after each await. That's also possible, but for simple cases, this is just easy. Find a place, it's if mounted. That works just fine. Okay, so this is one trick I wanted to show you. And this is an actual code. This is the state class. We have a counter. We start the start counter here. There's an async function, like spawning a thread almost. And while mounted, as you can see, don't do while true, because when you go to another page, this function will keep executing. So you don't want that. While mounted, and we wait a little bit, and then set state to increase that. But if mounted, because if we move away, you don't want an error to happen here. Okay. So this is the first tip that I tried to give you. Another thing that I do usually when I'm doing using stream builder or future builder, especially using nested functions of Dart to make it a little less boilerplate looking, like a little less boilerplatey. So as you remember, it looks kind of like a boilerplate stream builder, error, etc. So where is my actual UI? Sometimes you ask. I like to create a local function in my build function and call it really build. Put it in the beginning of my build function. So whenever I go to this function, I see, oh, okay, this is the actual UI, rather than trying to look for it in the stream builder, and just call that in my stream builder with the data. So this is, I think, a nice pattern if you don't want to get lost in your stream builder, future builder boilerplate. Another thing that I want to say before we move on, so build function can be called many times for various reasons, and the build function's role is, I have some data, let's create a UI from it, okay? It's not, let's start an HTTP request. You don't do that in your build function. You're not supposed to. It's just a like a pure function that gets some data, creates a UI. The data is already there. If it's not there, just create whatever you can. Don't start anything, basically, in your build function. Don't initiate a network request, for example. So this code on the left is actually taken from the official Flutter videos. Of course, they couldn't put a long code there. They were just trying to get a point across. But this is the wrong way of doing it. Let's see. In your build function, you call the future builder constructor. To its future parameter, you give the result of the HTTP call function, which initiates an HTTP request. So what happens? This has to be executed for this to be executed. So every time build function is called, another HTTP call is sent. This is a bad thing to do, especially like if you're an animation or something that keeps calling the build function. You'll again and again do HTTP requests to the server. The user's data plan and your server, billing will suffer. Instead, what you should do, you should have a stateful widget, and in your stateful widget, you should have a future final, of course. Sorry, and your init state function does the HTTP call, and you use that future in your future builder. Okay, you don't do it like this. You do it like this. Whenever you're using future builder, it should be a variable in your class. Otherwise, you're going to run into issues. Okay, here are some resources, and I want to demonstrate this for you in a second. I think we still have time, right, Victor? And I want to say happy async program.
Go for it.
Okay, just wanted to give a Midsommar reference again here. Okay, so let me quickly try to do something here. And we have the example Flutter code, the beginner like new project after all the comments are removed. So I have this going on, and let's just put also I hope this will give some IDE usage example for some people. Let's just create a raised button here, right? And you save it. Hot reload is perfect. On pressed, and if you're in the dev branch, you get this nicely. And like now I can press it. So let's start like I had it around here. Oh crap. Yeah. So let's start like a HTTP call, right? From the Flutter documentation, you see, oh, you need to import the HTTP package, which I already did, I believe. Yes, okay, which I already did. And then we want to import it. Since it's a named import, I have to do it like this, but otherwise it will do it for me. And now we need to, let's get the, let's do this. Okay, so we're starting an HTTP request. Yeah, let's save and see if it works. It probably works, who knows. But what does it return? Assign value to new local variable. Oh, this returns a future. This is the future HTTP response type. Great. I don't want that. I want to await on it. Okay, I'll enter, assign to new local variable response. But as you can see, I have my await underlined at async modifier. Great. So you can see IntelliJ is writing most of my code. And let's rename this to, I don't want to do that. Yeah, the response, what's the response? Type annotation. Well, it's an HTTP response. Great. So I can work with it. And how can I can do JSON decode response body. I don't have to do the import. It will do it for me. So JSON dot control space imported dot decode response body, right? Okay. So what does this return to me? It returns a object. So I cannot assign it to anything. It's a dynamic, sorry. Let me do like print decoded, let's call it, right? coded. Okay, so if I hit download, yes, it prints it, and I can also do a breakpoint here. Okay, decoded. Let's look at it. It has a title. Let's do which I already did it before. Sorry. Let me just show it. Decoded title, and yes, so this is great. I can copy name and then make use of it, perhaps. So this is more or less a quick way to do things sometimes. Yeah. So since it was already debugging, hot reload didn't work. Okay, now we have decoded title is printed. Great. Okay, so what do I want to do with it? I want to let's say we have like a loading. It's null by default, so I do is loading. And so yeah, right before let's actually before doing that, perhaps let's put it to a new widget just for the sake of it. I'd like to show this off. Extract Flutter widget downloader. So it actually created another widget for me. So things are more contained. I don't need the constructor. Okay. So let's put this in a column. Let's put a so it's downloading. And then is downloading. Then circle progress indicator, else, I don't know. And we can put it something there later. And a comma, I believe. Yeah. Okay, so let's put this into a title variable, right? Let's actually split it and let's actually move it up here. Okay, and perhaps make string, right? Capital S. Okay, and here let's put that. Okay, so now I have a downloading widget. Yeah, title cannot be null. And I'm changing the state anyway, so I may have to hot restart at some point. But it's downloading, but it's not showing, so I have to do the hot restart. Oh, I didn't do the set state. Sorry, that's the issue here. I need to do set state. Oops, set state. Oh, I'm not a stateful widget, so let's convert it to a stateful widget. Very easy. And let's do a set state. Move this title inside it. Oops. Okay, so soon need a hot restart. Yes, so now we have it over there. So we download it, we show it. So let me put a like a 1 second delay here. Seconds 1. So it takes a little more time, or 2 seconds. So now I will try to demonstrate that issue for you. But yeah, mine is downloading. Yeah, because I never actually used this downloading, right? So I need to do set state is downloading true. And I want to do a try catch, right? What if it fails? Try finally, sorry. I never wanted to stuck at the is downloading. Is downloading false. Okay. So now, yeah, I see the downloading thing for 1 second, more than 1 second, because there's actually download. So what I want to do now is I want to create I want to do it in the second page. I want to do it in a second page. So set let's create a stateless first page widget, and actually here create like a raised button. Pressed. Let's go to the next page by saying material page route. Sorry, navigator of context push material page route. And I have to cheat here because I got excited somehow. Yes, I used the constructor. I need to give it a builder. It's going to be return. Yeah, actually this is fine. Oops, the other anyway. Return. This is my home page here instead of that. Okay, now here I return the first page. Okay, so now this is the first page and this is next page, but not the erase button, is it? Oh, it's a button. Okay, but it's a huge button because it's a container. I should center this perhaps. Oops. Let's go back there again. Yeah, okay, this is a little better. Okay, so I have a first page. This actually let's do a hot restart, so start from the beginning. I have a first page, I click on it, I go to the next page. And my download will start here. And while that's continuing, right, so this function, this async function, it's going to say is downloading true. It's going to start some await, some asynchronous calls. While that's happening, I'll move away to the first page. But this won't stop, of course. This will go to here, and it will hit the set state, and boom. So let's see that. Let's start download and go back. And then I should, yes. So we got the exception. And you know, if you try to look at the logs, you'll see somewhere set state called after dispose and tries to explain. You put it to Google, of course, you see Stack Overflow answer, but I already told you the answer. So instead of set state, let's say set state if mounted. So after the awaits, right, all my set states as if it's there, and then create a method, and then let's at least call it F, and then if mounted set states F. Yeah, I hate when people don't do this. Set state. No, sorry. F, yes. Okay, so now I'll set state if mounted. This also and that. Yeah, so this should prevent that error that we had earlier. Next page. Yeah, 2 seconds is enough. Go back. And no problems. It printed something. Title apparently came in empty, but we didn't have the exception anymore. So this is something that you'll run into, like I said, whenever you have await followed by set state, then it should be either set state if mounted, or it either should be if not mounted return, which is a better way, but you need an extra line. You have to remember to put it, but just set state if mounted is a nice pattern for me that I found, unless there's something more complicated going on. Yeah, so hopefully I also showed some IDE features. I'm in the dev branch, so this control space for the functions might not work. Earlier I showed you with the builders. With the stable branch, it wasn't working, but the dev channel, it's working. Yeah, so this is all I wanted to talk about. If there are any questions, I'll be happy to answer.
All right, thank you. That was actually really interesting. I learned a few tricks that
Really nice.
I'm sure I'll put into my code in the future. So thank you for that. And if anyone has any questions, feel free to either ask in the chat, or you can, I think, raise your hand somehow in Zoom, and I can press the allow to talk button there.
Thank you, Alvaro. Thank you,
yeah, there was a couple of things that I haven't worked with the way you did it. Like I always check. I don't make a method for like the mounted thing. I usually
it's a horrible bug.
It's easy to forget.
Yeah.
And yeah, I've run into that bug more than once.
Yeah.
I wonder, it feels like maybe set state should work that way by default.
Yeah, wouldn't that be nice?
I don't know. I'm sure there's some reason why it's not.
Sure. I didn't look at the issues and everything in the GitHub repo, but I'm sure there's a discussion somewhere about it. I just wanted to get it working.
Yeah. All right. Well, we have a question answer here. Let me see. Can all on-click functions be asynchronous?
Yes, that's a great question. And the answer is yes. If what the function returns, if it doesn't matter, you can put async there. So on clicks, earlier you saw I was converting it to async. Maybe I can switch to the code. Yeah, so this after first await, I hit Alt Enter, it put an async here, and it's converted to async. And since what it returns is not important, it works just fine. And if you actually look at the signature, it says void callback, but apparently, async functions are also assignable to this. So the answer is, if what it returns is not important, you can just use async. You can convert your main function to async if you want. But things that cannot be async, this build function cannot be async because it has to return a UI right now to the screen. Something has to be shown. The init state cannot be async. It's somewhere, I guess. Anyway, init state cannot be async. Those have to complete immediately.
I'm also curious about, you did like a lot of fancy refactorings and stuff. Is that like the default IntelliJ or?
Yeah, it's just the default thing. I highly suggest this. I wanted to show this slide later. I highly suggest this from Pooja Bahumik. I'm not sure if I'm saying her name right, but this says it all. The STLS, etc. It's definitely worth your time to check for Visual Studio Code. There's there's the Visual Studio Code version of that, which has pretty much everything the same, all the same features.
Yeah, I feel like you can save a lot of typing there.
Exactly, and this is one of the reasons I love Flutter. It's so fast to do things. So one other thing, if you're not using it, for example, Flutter Inspector shows you the current UI hierarchy, the actual objects, and you can just, instead of saying, oh, where was this download, etc., you just click here, it takes you to the code. It should. Raise button, yeah, so it took me to the raise button, as you can see, to the download. So when you want to continue with your project, you just go to where you need, and then you click on this here, and then you found the function, you start coding.
That is really cool. Actually, a feature. Is it in the latest versions or on the beta?
No, this inspector works in the stable version. So everything I showed works in the stable version except for this. Let me find one. This builder stuff. Now I'm excited again. Builder. Yes. So okay. So it's asking me for a function, right? And I hit Control Space. These two don't exist in the stable version, stable channel.
Okay.
But it's so convenient. I'm not sure. Maybe in the beta it may be there. This is dev.
Yeah. All right.
But everything else is there in the stable.
Very cool. All right. I don't see any other questions, so I guess we've been an hour, and that was the planned time for the meeting. So thank you so much for your presentation. And is there a chance we can post your slides on our Slack channel?
I'll send them to you via email. I can share it in Twitter. We can do all.
Awesome.
And
yeah.
Yeah, I just wanted to say, touch typing, beginners sometimes ask, what can I do to improve my programming? You have to not look at the keyboard when you're programming. And the way I found that works the best, because I use the Dvorak keyboard, at some point I switched to it. And the way I did it is you just print this out on the wall. So instead of looking down, you look up, and then after a while you get used to it. That's how I stopped looking at the keyboard.
I just decided not. I guess I covered my keys at some point.
Yeah, so that's another.
But I actually use two keyboard layouts. I use American keyboard for programming, and a Swedish keyboard when I'm typing letters and stuff, because there's a.
Do you have the full enter key, or is it like did it steal a piece of the enter key, the Swedish layout?
So I sort of got used to. Right now I have the Swedish keyboard, which is slightly different from the American keyboard.
But physically it's the same, right?
No, they are slightly different. Okay. It's the enter key that's different. You're right.
Yeah, just like in this picture, ours is like this too, but some enter keys are a little larger, so I like it better. So I actually changed this key. I'm not sure. Yeah, you can see it. I actually changed this key to enter because my little finger reaches that.
Oh, that's some advanced stuff there. All right.
If anybody wants to reach me, gazialankus@gmail.com and my company. Yeah. So my Twitter is gazialankus. I'm everywhere. Feel free to reach me. Someone said in the chat, yes, it's recorded in YouTube.
Yes, should be.
Maybe we can get the link to.
So I'll post that on Slack too, so people can watch this later. And yeah, thanks so much for joining us. And I hope we get a chance to talk again. And
yeah, let's keep in touch.
If you ever visit Sweden, please come visit us at Flutter Sweden too. And
thank you. I wish. I hope. I have some family in Germany, in Düsseldorf. Maybe if I swing by. If you want to come to Turkey anytime, if anybody I will be glad to help. Happy to help.
Awesome.
Happy to host.
All right. Thank you very much.
Thank you very much, everybody.
Bye.